Okay, so he has given so many isomeric structures of benzenes in which all these structures have 6 number of carbon atoms and 6 number of hydrogen atoms, but they are all not benzene. Only one Kekulé formula he has put in front of us as a benzene. Later on, he has done an experiment, that is conversion of benzene into mono-substituted derivatives. In that, he has done the substitution of bromine in the benzene. Whenever benzene is go for any substitution type of reactions, he will substitute his one of the hydrogen atom. Now we know the structure of benzene, C6H6. Now one of the hydrogen atom of benzene is substituted with that substituted product. So when bromine is an substituting agent, benzene will convert into bromobenzene, that is C6H5Br. It is obtained when hydrogen atom is replaced by one of the bromine atom. Similarly, chlorobenzene, when one of the hydrogen atom of benzene will substitute with chloro and followed by nitro. When the nitrobenzene is formed, when the nitrous group is substituted in the place of one of the hydrogen atom of benzene. Now, okay. Now what happened next? This fact places a similar severe limitations on the structure of benzene. We know the fact benzene is going to substitute only one of the hydrogen atom with the help of substituting agent. But this fact places severe limitations on the structure of benzene, as each hydrogen atom in the benzene must be exactly equivalent. We know the Kekulé structure of benzene, but all the hydrogen atoms are exactly equivalent to every other hydrogen atom, since the replacement of any of them is the same product. So all the hydrogen atoms, how many hydrogen atoms? 6 hydrogen atoms in the benzene are there. So all hydrogen atoms are at equivalent position. So out of that 6, any one we can substitute with the help of substituting agent, that any one of the hydrogen atom will give the same product. Now what happened next? So structure 5, already we have discussed these all structure. So structure 5, that means this, for example, must now be rejected, because what Kekulé has put forth in front of us, all the hydrogen atom in the structure of benzene are equivalent. But this is not the case with this structure 5, since it would yield 2 isomeric monobromo derivative, because the hydrogen atom in this benzene are not equivalent. So they may yield a different product. So what are those different products? That may be 1 bromo and 2 bromo compounds, as all the hydrogen atoms are not equivalent in the structure number 5. Similar reason shows us that structure 2 and 3 are also structure 2 and 3 also have, or structure 2nd and 3 also, there will not be equivalent hydrogen atoms. So if we substitute these 2 compounds with any substituting agent, they will not give a same product. These are some of the reasons why all these 2, 3, 4 and 5 structure are rejected according to Kekulé's theory. And we have accepted only one structure of benzene, that is this one, structure number 1. However, benzene yield 3 isomeric di-substitution products. Now benzene is undergo di-substitution also in severe condition. Generally, benzene restrict the addition of compounds into it, but In severe condition, benzene will go for disubstitution product. Benzene will go for disubstitution product. So he is going to produce. That means we can expect 3 isomeric dibromo derivatives. Say 1,2 dibromo derivative, 1,3 dibromo derivative, and 1,4 dibromo derivative. In common language, we can call these structures as a 1,2 orthobromo derivative, 1,2 metabromo derivative, and 1,4 para dibromo derivative. So, in severe conditions, only benzene will go for disubstitution reactions. Now, closer examination of this structure 1 and closer examination of structure 1 shows, however, that 2,1,2 dibromo isomers, that means 6 and 7, differ only in the position of bromine relative to the double bond. So, in the structure of 6 and 7, if we can compare both these structures, the difference in these two structures only the position of double bond. In the structure of 6, the position of double bond is starting in the clockwise direction, and in this case, the position of substitution of bromine in this case is in clockwise direction, whereas in this case it is anti-clockwise direction. This much only the difference between these two structures. So he described it in terms of two structures, that is structure number 8 and 9. He has removed the benzene and directly write down the structure of only benzene molecule. He has removed bromine and written down the structure of benzene molecules, that is structure 8 and 9, with the benzene molecule who has alternate double bond. As a consequence, the 2,1,2 dibromo derivatives, that is 6 and 7, would be in rapid equilibrium. So they will change in between these. Means the structure number 6 and 7 will be changing vice versa. The structure 6 will convert into 7 and 7 will convert into 6 at any position, and they will not be separated out easily. So there will be an equilibrium between these two structures. That means there will be an equilibrium between these two benzene structures also. So later, when the idea of tautomerism comes, what is tautomerism? He has defined it was so later when the idea of tautomerism become defined, it was assumed that Kekule's alteration. What is Kekule's alteration? These two structures of benzenes are only in this. See here, there is clockwise starting the rotation or conjugation of double bond. In this, it is anti-clockwise. But these two structures are same. They all have equivalent hydrogen atoms. They all have equivalent carbon atoms, and so these two structures are tautomers of each other. So what is tautomerism? It is nothing but a phenomenon in which there is either shifting of electron or shifting of hydrogen atom takes place. Now here in this case it is shifting of electrons from one position to the another. So whenever there is shifting of either electron or hydrogen atom, in order to attain an stability in the structure, this is known as tautomerism. So here there is shifting of electron to obtain an stability. So this is also a two tautomeric structures of 1,2 dibromo derivatives. So stability of benzene ring. Up till now we have studied what is benzene. It is anaromatic in nature. It is generally undergo substitution type of reaction. It will not undergo addition reaction. Now, why the structure of benzene, or what are the properties that structure of benzene is stable? So for that, first we will discuss some of the reactions of benzene that you have already discussed in your 12th or in first year. So those are, there are number of facts that are still not accounted for by the structure. Kekule has given the structure of benzene, given some of the properties of benzene, but there are some facts still we don't know. And most of these are unexplained. These facts seem to be related to unusual stability of the benzene ring. What are those facts? Those facts are due to the unusual stability of benzene ring. The most striking evidence of this stability is found in the, and this stability we can discuss while we can discuss the reactions of benzene. Now, we all know benzene generally undergoes